Hello, everyone. My name is Evelio. I work at Facebook as an engineering manager. I work specifically on WhatsApp, and today I'll be talking about what we do to shrink WhatsApp. To tell you a little bit about myself, I've been doing mobile development for about 10 years. I actually started as a freelancer, and then I joined a bunch of startups. As you might know, like most startups fail. But the ones that you recognize the most are Snapchat and Lyft, which is a ride-sharing application. Anyways, I was delighted last year when I got the opportunity to join Facebook and work on the application that I use the most, which is WhatsApp. So to tell you a little bit more about WhatsApp, I have a series of videos that hopefully gets you an idea to understand how we look at WhatsApp internally, which might be different from your perception. So at WhatsApp, we're a very small team. When you think about it, by Facebook standards, it means that absolutely every single engineer supports hundreds of millions of people, which is incredible. So we have a clear mission, which is building a simple, private, and secure messaging service that works fast and reliable anywhere in the world.
Você não precisa de uma equipe grande nem de habilidades especiais para fazer a diferença. Você só precisa de pessoas que queiram se doar. Eu sou Felipe, filho da Valéria, e nós somos os fundadores da Caravanas do Amor, uma ação social que leva doações a comunidades isoladas de Minas Gerais. Coletamos um total aproximado de 21 toneladas de doação, com itens como comida, brinquedo, roupas e material escolar. E saímos em grupos de São Paulo para pegar a estrada e fazer as entregas pessoalmente. As comunidades atendidas ficam na periferia. Às vezes estão em áreas com pouco sinal ou problemas de conexão. Mesmo assim, podemos usar o WhatsApp para mandar e receber mensagens. Hoje, a nossa família é composta por mais de 1.500 outras famílias de Minas Gerais. Minha mãe me ensinou que a vida só faz sentido se formos caridosos e servirmos aos outros. Ajudar essas pessoas me deixa muito feliz.
Just like him, I'm very happy and very proud of being able to work in an app that enables connecting people and work on such noble causes. So, just to recap, WhatsApp, simple, reliable, secure messaging, which means on Android, we don't really want to leave anyone behind, and we support like very lower API levels. If I'm not mistaken, up until last year, we actually supported still Gingerbread, which is crazy. So we focus deeply on low-end devices and supporting really old devices as well. So one of the core values for WhatsApp is simplicity, which, depending how you look at it, an example from a perspective, you would think, okay, let's keep it small. And on the product side, it could mean delivering fewer but higher quality features. On the engineering side, we take this value and we leverage platform limits to keep the application small. But you might wonder, how do we look at app size from our end? So you can look at app size in different dimensions. So an example, for an universal build, we can look just at the raw APK size. You can also look at the Play Store numbers and see your download size. And there is also a component to it, which is when you update, how big is the delta of your update. And when you look at the world, not everyone is well connected. So we see like this beautiful blob, orange blob in Europe, Belarus. It might not be, it has good connectivity compared to the rest of the world if you look through that lens. So we don't want to leave anyone behind, and we want to make sure that you are able to not only download, but also update the application. So on top of this, you can also look at it in when the application is installed, how much space do you take? Because when you support low-end devices, it means that they have limited storage. So we continuously keep an eye on these different dimensions. And by leveraging Facebook infrastructure, we have like multiple dashboards. And if you walk around our offices, you will see like all these graphs, and everyone is aware of these different dimensions. So for app size, precisely, we look mostly around method reference count and the APK size in different dimensions and splits. We also leverage Facebook infrastructure. An example, this is Fabricator, which for most people will be using GitHub. It's like a pull request. So you can use a series of bots to measure these different things. So an example, this is a run of the app size bot, and it will tell you like the breakdown and the delta between, and the difference between your base commit and the commit that you're trying to get in. We also have bots for performance. We don't collect much data on production. We try to make sure that the data we care about is controlled under a lab environment. So in this example, I had a run of cold start time. And like, you know, it's Facebook, so there is a like button on everything. We also use tooling from Google, such as an Android Studio. We just, you open the APK and we explore it. So speaking of which, I'm going to make a note on delivery. So how do we ship the application? You can download it from our website for cases in which you don't have the Play Store installed. But like everyone else, we use the Play Store to distribute it. So as you might hear, like I believe it was last year's Google I/O, they announced Android App Bundle, which is a new format for distribution. You probably have seen this GIF in which the way it works is that they tailor the APK for your configuration and your device. But for WhatsApp, because of the promise of end-to-end encryption, we cannot really use app bundles. We don't want to give Google the keys because it could mean that they alter the binary that we're shipping to your device. So we securely keep the key, and we don't share it with anyone, not even Facebook. So what do? Well, we keep the application small and never share this key. So we use tools like APK splits, which means you can declare it if you use Gradle. You can declare it on your build.gradle file by explicitly declaring the densities. In example, in this case, we will be splitting by density. And this meant for us 1 or 2 megabytes of savings compared to the universal APK. You can also split by ABI. And in example, we support only 4 of them. And these are the ones we use. This actually meant a major reduction for us because we have quite a bit of native code. But this increases the complexities of management, on release management. Luckily, we have engineers that help automating these different things. So as I mentioned, your mileage might vary. As you notice, this is very WhatsApp specific, so I'm sharing a lot of the optimizations that we do. Maybe you will find something useful for your app. So you probably had done this exercise already and wonder what exactly is an APK. So you know that it's a zip file, but it's interesting to see that in the APK, not all the files are compressed. So there is also an overhead around metadata and timestamps. So by repackaging and stripping metadata, we observe a reduction of 1 megabyte. And in example, you can run this command to find out what files are not being compressed. There are some details around whether you want to compress certain files or not. In example, I believe that TensorFlow wants your models not to be compressed. And like that, there are some caveats in terms of performance that you might want to make sure that there are no regressions on your end. You can also leverage default built-in tooling. As I mentioned, if you use Gradle, this is the default. But an example, we found the case in certain Facebook apps, they were still using jar signer. So if you switch to modern tool chain, you could also observe wins. And like that, you might see some progressions if you try to zip align it, but the zip align is very small and apparently it has benefits at runtime. So after we got to know what exactly is an APK, we can explore exactly what's inside it by just compressing it, and you'll find stuff like your manifest on binary format, all your assets, your native libraries, this Android resource file binary format, signing information, your code, which is represented in a DEX file, which is also another binary format for your bytecode, and finally your resources. So the first thing that you might want to do is just remove stuff by opening an Android Studio and finding stuff that shouldn't be there. So we did this, and we found a lot of stuff that shouldn't be there, and it mostly comes, funnily enough, from third-party libraries, such as Google's or Android's libraries. So you can strip securely all of these things, and for us, it saves 300 KB. You can also do something interesting, which is stitching stuff. So an example, we have to, because we want to make sure that WhatsApp is usable offline, we currently ship emojis in there. So like as a series of PNGs on the assets folder. But we thought about it, and we started looking into another way to store these things. So we call it flat file, which basically what you do is take all your files and stitch them together in a single file. And we just keep track of the offsets. And you can also compress it even further if it's beneficial. Keep in mind that this might be counterproductive for deltas on updates, because you are adding entropy to your files, and like the algorithm that they use on Google sites might not account for that, because they look like completely different files. So an example, for all the emojis that we have in file, like in the APK, we save 300 KB on zip metadata, 124 KB on signing information, by a total gain of 400 something KB. You can all look at your resources and probably have enabled this link rule, so it warns you about unused resources. And you can also enable this flag to shrink your resources. There is also options that you might see some regressions around PNGs, so you can opt out of the default cruncher. So we use a series of tools that help us make the PNGs smaller. An example, we try different variations of them, and the one that worked the best for us was softly PNG, which reduces the bloat by 2 MBs. And unluckily, we cannot use WebP because we support lower API levels that don't have really WebP support for resources. We do use SVG for things like doodling. We also use vector drawable, but not extensively enough. This is because, as you might know, vector drawables and these XML-based formats, vector formats, might cost a runtime, inflating them, parsing them, and rendering them, as opposed to a raster image. You can also use restrict the amount of configurations that you have. So by doing this, we save 1 MB. Which is a nice segue into strings. So it's very interesting that in the Android resource file, you'll find that not only all the information about your containers, but they also use a series of offsets or references. So in example, each one of these string entries references take 4 bytes, right? So in example, we have these 5 strings, and then we have only one configuration. It means that it costs us 20 bytes. So in example, let's say we add an override for B21 to change the string feature to new feature. You could think that it would be just 4 bytes, right? But in reality, they pad most of this information with no values, and it ends up costing 20 bytes, which is interesting. For more accurate numbers, imagine that you have you support 50 languages, and then you have a lot of strings, and you override multiple configurations, so it gets big quickly. So you start thinking about other alternatives. You could just put your string in code, but then you will bloat your dex file. Maybe think about another format. So we did this exercise, and we created something called string packs. It's going to be open source soon. String packs save us 8 megabytes. Now, looking at the bytecode, you can also do an interesting exercise. And for example, I'm very proud to say that WhatsApp is still a single DEX application, which is not very common nowadays. Yep, there it is. So the way that we approach this is we favor smaller implementations. In example, we have our own internal implementation of TLS 1.3, which is much smaller compared to other open source solutions. We also take a look closely to our dependencies, and we make sure they are constrained to the configuration that we care about. And of course, you can enable built-in optimizations to enable shrinking, but make sure that you use the proper file, because otherwise you won't get the optimization that you might expect. And as usual, you can also declare your own rules. So last spring, I enabled arrays for our builds. And for us, we observe a regression of 168 KBs. But we noticed an interesting reduction on method reference count and improved cold start. However, like some people in the community have observed regressions on different metrics that they track. So, in example, when we look at the unoptimized version on the bug, you can see that it's a pretty sizable amount of methods. By using ProGuard, we were looking at these numbers, but Array does a better job at reducing this. But you might think, wait a minute, this is still like over the limit. So we use a tool from Facebook called Redex. This is the website if you want to check it out. But Redex is a fantastic tool. It's pretty interesting. It does a lot of optimizations for you that might help quite a bit. So the way it works is that you feed it your APK, and then, of course, you will provide a path to the output that you want, and you can also provide a configuration. Something interesting that we discovered recently is that you can also feed it all your dependencies and even the framework jars, and it will do a better job at optimizing. So let's look at one of the configurations, sample configurations that you can use for multiple passes. So I'll talk about some of them a little bit. So in this example, synth pass is an optimization that removes synthetic methods. A synthetic method is something that the Java compiler generates to work around access flags. In example, if you have a private property and maybe an inner class, and the inner class access the outer class property, it would generate access synthetic methods. So you can, what Redex does very interestingly is removes those, and it might publicize your property, which at the end of the day, you don't really might not care about it at runtime. There is also a pass such as final inline. What it does is that whenever it can and it finds final values, it will try to inline them in such a way that you don't have to look them up. Optimizations such as deleting super calls when necessary is pretty common on Android, since like you have this series of callbacks that might not have any implementation at all. There is also something interesting for people that like abstractions. So you can have, an example, an interface and if a single implementation of it. So what Redex does is actually can mash it together in a single class, which saves on DEX. There are also other optimizations such as method inline, which basically does, let's say you have a private method that you only use once. You could inline that in the call side and then save that method reference and the method altogether. So when looking again at the optimized version, the ProGuard version, and the combination of ProGuard and Redex, we are still over the limit. And as I mentioned, Array also over the limit, sorry. And then the combination Array and Redex puts us just under the limit, which is terrific. So make sure to check it out, try it. Let me know if it works for you. There's plenty of long-hanging fruit still. So, an example, we still could provide a much better R8 and ProGuard configuration to make sure that both R8 and Redux do a better job at it. We can also add a bunch of different Redux passes that we are not using. There's so many of them, and you can check them, it's open source. As I mentioned before, we want a lot of stuff in the APK, mainly thinking for the use case in which you are offline. But I believe that this can be solved by making these things downloadable. It's a little bit challenging when you have billions of people using your application. You have to do it in a smart way, in such a way you don't slam your servers. We could also look into dynamic features, which is different from app bundle. Interestingly enough, this tooling generates separate APKs. You can actually create them yourself, maybe ship it to the store if you could. On top of this, there is like this overlook format called OBB, which allows you to have expansion files. So there is plenty of opportunities to do that. An example, Facebook has internally a project called Voltron, which leverages dynamic features to be able to download separated features at runtime. We can also look at other formats, as I mentioned, vector drawables, maybe use Facebook's keyframes. I believe there is an open source library called Lottie that enables animations, and I think the key difference is that Lottie uses JSON versus keyframe uses a smaller binary format. As I mentioned, WebP, we could start looking. We definitely do some work around stickers to decode WebP at the cost of CPU on lower devices. So we could start leveraging that for resources as well. And there is also this new format called Basis Universal, which is pretty interesting for raster images. Could be an alternative to JPEG. There is plenty of work that we still have to do on install and download size. In example, native library optimizations, by looking at your output on Bloody, you can find opportunities to shrink this even further. And in terms of compression, you can either disable no compress in such a way that you can read it directly from the APK, but alternatives such as what Facebook does, which is compress it with zip standard and inflate them at runtime, which, the trade-off is, storage, runtime performance. So that's all I got. Thank you very much for listening to me. And of course, we are hiring. So we're hiring across the board: designers, PMs, engineering managers, engineers, of course. So shoot me a note on Twitter or on LinkedIn if you are interested. So for that, I'll open it for Q&A.